Section 1.3 is all about tying functions into mathematical models, and specifically we'll be looking at linear functions. So before we actually start some examples, let's just talk about some review concepts and words, vocabulary that you should be familiar with. So some conceptual questions. First of all, what is a function? So again, this is section 1.3. So what is a function? You can give lots of different answers. I'm going to give a layman's definition for it. There's a technical definition in your textbook, but what we're really after is the fact that each input, which we usually think of as X, corresponds to a single output. So each X value gives you exactly one output or Y value, and that's what defines a function. So it asks to give an example of a function. So it could be your paycheck and your salary. So if you work X hours, then you get Y dollars. If you work a different amount of X hours, then you get a different amount of Y dollars. So the calculation for a salary, an hourly wage based on your number of hours worked would be an example of a function. One input, one output. Don't forget that the notation for function would be an f of x. So in the last section, we saw y equal mx plus b. We're going to translate that into function notation and write that as f of x equals mx plus b. So an example of a linear function would be something like 1/2 x plus 3. You would still come in and graph this the same way we did in the previous section using the slope and the y-intercept. We're just using function notation. Notice it fits our definition. If you put in one value for x, you'll get out one value for y. What's the domain of a linear function? Well, because it is a line, if we come to graph it, this particular one has a y-intercept at 3, and the slope says to go up 1 and over 2. So when I take a look at this, the domain is the set of input values. It's the set of x values. So what kind of numbers can we plug into this function? Well, I can definitely plug in whole numbers, 1, 2, 3. I may not like the outputs because they'll be fractions, but I can plug them in. I can also plug in negative numbers, but I can also plug in fractions themselves and decimals. So what we're saying is the arrows on the end of your line tell you that your domain goes from negative infinity to infinity. An alternative way of saying that, or you could say that as all real numbers, and that would be an alternative way of stating that exact same answer as an interval. So what about its range? Well, the range is the set of y values. And for a linear function, just as it goes out left and right, it's also going up and down. So this arrow over here is doing this. The arrow on the other end is doing this. So its range is also from negative infinity to infinity. We're recognizing you can plug any number you want into it, and you will also get out of it any number. And that's what it's saying. And then finally, the last conceptual question is it's asking what's the independent variable and what's the dependent variable. These are terms that are sometimes used for the input and the output. So the independent variable is your x, which is your input. So it's easiest to remember the in in input goes with the in in independent. It's the one you get to pick. It's independent of what you're doing. The dependent variable is your output or your y value. And it's the output because it depends on what you put in to the function. So it's the output. If we take a look at our linear function again, you're plugging in x's as the input. They're independent because you can randomly pick those. And you get out of it the corresponding y value, but it does depend on what you used as an input. So again, just as a kind of background, remember what a function is, one input, one output. Don't forget that we have linear functions. We can graph those just like our equations that we were graphing. The domain is a set of input or X values. The range is the output or a set of Y values. And the independent variable is always our X, and our dependent variable is always our Y. So the rest of this section is spent using applications that are linear functions in the business world. So let's take a look at one of those. So example one that I'd like to look at states an automobile purchased for use by the manager of a firm at a price of $24,000 is to be depreciated using the straight line method over 5 years. Straight line telling me it's going down in value over 5 years. What will be the book value of the automobile at the end of 3 years? We are going to assume that the scrap value is 0. To get a handle on this, let's actually graph what they're telling us. So on our axis, what we have on this axis is actually time. And on this axis is the value of that car to the firm, to the company. We know that time 0, we purchased it at time 0, and it was worth $24,000. We're going to depreciate its value over 5 years and assume the scrap value is 0. So at year 5, it's now worth nothing. And it's a line because they told me that. So that's what the line looks like. So what we're going to do is we're going to come in and find the book value at the end of 3 years by writing the equation of the line. So our very first step, so step 1, is to find slope. We need the slope. Good thing we know how to find the slope. We're going to do y2 minus y1 equals x2 minus x1. So y2 is 0 minus y1, which is 24,000, all over x2 of 5 minus x1 of 0. It's going to give me a negative 24,000 divided by 5. And it's a negative slope because it is decreasing in value. So the answer is making sense. Let's go ahead and divide that out. 24,000 divided by 5 comes out to be a negative 4,800. A much friendlier number to work with. You noticed. We're going to write the equation of the line. We like y equal mx plus b because they gave us the y-intercept, because we were given the y-intercept. So I do not need to go through the point slope form. I can simply come in and write this function as y equals a negative 4,800 x plus the 24,000 of the purchase price. So now if you tell me a year, I can tell you what the car is worth to this company. So step 3 on that problem, what we're going to do is come in and let 3 years. Yeah, we want to know what the book value is at 3 years. So we're going to let x equal 3 and plug it into our function or our equation. So again, what we're really finding is f of 3. Notice how I wrote that as a function now, just to remind you. So that's negative 4,800 times 3 plus the 24,000. So you can multiply the 4,800 times the 3, make it a negative, and then add 24,000. And if you do that, you should end up with a value for the company of 9,600. Now, why would you need this? Because you have to claim it on your taxes as part of your assets for your business. So in year 3, this car is worth 9,600 to the company.